The second reaction involves the addition of alcohols, ROH. Now, of course, ROH could be methanol, ethanol, propanol, etc. So be able to recognize those alcohols. But we're going to use, for this example, the simplest alcohol, which is methanol. So let's look at the base catalyzed reaction. So we have a carbonyl, type 1 carbonyl, whether it's an aldehyde or a ketone. We react this with methanol with the anionic form because it's base catalyzed, and the outcome would be the following. Right, so you were able to add the OR part to the alcohol, to the carbonyl, and you also have the alcohol group. That's what I meant to say. And you have the ether group. So this is there's a name for this. This is called a hemiacetal. And this reaction can't go anymore toward what we call an acetal, simply because, again, it just stops at the hemiacetal. So let's look at the mechanism. It's similar to the mechanism you've seen above with the addition of water. So you have OCH3 minus. It's a strong nucleophile. Let me draw the arrow in a better way here. Minus. And then you have the methanol as your solvent, and it can help protonate the charged oxygen. So here's your hemiacetal product. Now let's look at the acid catalyzed reaction. Once again, pick up patterns from what we did before, where we had an acid catalyzed addition of water, hydration reaction. Mechanism will be very, very similar. Again, the only difference is you have now an OR group attached versus an OH group. So let's look at the acid catalyzed. So the first step would be to well, let's actually first write the reaction. Oops. OH. Okay, so we form the hemiacetal. And then it goes all the way now to the full acetal. And the full acetal has a 2 OR groups attached to that former carbonyl carbon. So that's called an acetal. Now, there's one word to say about the hemiacetal is that it's not isolated. So the reaction has to continue. So it's very hard to isolate this, meaning isolate it from the reaction. So it has to continue all the way to the acetal. So the difference again between the hemiacetal and the acetal is that it has 2 OR groups on the acetal. Hemi means halfway through you have an OH. And let's look at the mechanism. Once again, you have to activate the carbonyl. So let's begin. You have the acid that protonates So again, the protonation of the carbonyl oxygen is first. Remember, as we discussed in the acid-catalyzed addition reaction, to make the carbon more electrophilic. So we have now all right, this just is playing with me here. There we go. Very well. So now we have the methanol attack. Since methanol is a weak nucleophile, and this is more electrophilic, the carbonyl carbon, then the attack can take place. Remember, this is an equilibrium method, so you have to draw those equilibrium arrows all the way through. So there's a positive here charge. You know what to do now. The positive charge has to go away on that oxygen, so you would have to deprotonate. And that would be from another methanol molecule. And here's the hemiacetal formation. Now let's go to the acetal formation, which is a few more steps to again get to the acetal. Now, what happens next is we bring the acetal, the hemiacetal down here. And this oxygen gets protonated from either the protonated methanol, we can use that. It's very acidic. There's a positive charge on it here. And now we have water attached. So we made that alcohol group, that hydroxy group, into water, which is a good leaving group. So water is a great or good leaving group. Therefore, the mechanism is that these electrons on the OR group, the OCH3 group, come down, and then the water is kicked out. It leaves. Now, another methanol let's just redraw that really quick. Is attracted to the activated carbonyl carbon. It's electrophilic. So the reaction will take place once again. Very well. And now we have a water molecule that was kicked out, or even another methanol molecule that would work too. So we'll just put the water molecule here, or even another methanol molecule would work as well. To deprotonate. And finally, you're at the full, or the acetal, which is the full product here. So here it is. That's the acetal.